Hey class, Mr. Houston here, back again to talk to you about Chapter 6, Lesson 2. We're still talking about similarities here. Today we are talking about how similarities and transformations work together. If you remember back to transformations from Chapter 4, our transformations were a reflection, a rotation, and a translation. Or as some of you might remember, it was a flip, a rotate, or a slide. Okay, one thing about all three of these transformations is that they preserved the size and the shape of the figure that we were transforming. We just simply changed the orientation, whether we flipped it or whether we rotated it around a point or we just slid it around. Today we're going to talk about a transformation that changes the size of the figure that we are working with, and that's called a dilation. Okay, so a dilation is a transformation that preserves angle measures and results in an image with lengths proportional to the pre-image lengths. So basically, we end up with a larger or smaller version of the figure that we started out with. Okay, just a concept here, nothing that you have to write down or anything, is that if we can say that a dilation is used to map one figure onto the other, the two figures are similar. Again, if you look and see, all the angle measures are preserved. We simply just have a smaller figure than what we started with, so the sides would be in proportion to each other. All right. So how we describe a translation or a dilation in this case is through what's known as a scale factor. And the difference between the scale factor we used the other day and what we're going to do today is that in this case, before there was no direction, but in dealing with a dilation, we always do the new length over the old length. Okay? So in the case of example number 1, we are talking about the dilation from FEG onto FDH. So FEG is this one right here. This is our old, okay, and then the entire one, which they said was FDH, that is the new. So we only need to compare one of the side lengths, because we already say that they are similar to each other. So we just compare the side lengths that we are given, and again, it's new over old. So if my big triangle is the new, I'm going to use this entire length here, and that's going to be 20. And the old length, which was just from here to here, is just 10. Simplify that down. Our scale factor in this case is 2 over 1. So the dilation is a 2 to 1 scale factor. So basically the new triangle is twice as big as the original triangle. Okay, that's really all there is to do when it comes to describing a dilation. You just describe it using a scale factor. All right, now again, nothing that you need to put down anywhere, but just understand that we can combine dilations and rigid motion transformations. So basically, we could say, how did we get from here to here? We would say that we dilated to DFE, and then we reflected across this vertical line. So basically, that's just letting you know that you can combine both dilations and rigid motion transformations, like a rotation, reflection, or a slide, all together. You can put them all together. All right. So example number 2 here. They want you to describe the combination of transformations that take place. We are going from triangle ABC, and we want to know how we move to FEG. So ABC is out here, and then we have triangle G, or FGE, which is over here. So first off, we can obviously see that we have to dilate down. There has to be some sort of dilation. We don't have any numbers to describe this, but we are going to say that we would dilate to triangle let's see, A, B, C would be D, B, E. And then if you look here, these angle measures are in the same spot, which means that we are going to have to rotate about point P. I'm sorry, rotate around point E. And that would give us our FGE triangle. So a dilation down and then a rotation about to give us triangle FGE. Okay? And then last, we also need to be able to look at this and see that there is not, they are not similar. Okay? As we look at this here, you can see that this triangle, or I'm sorry, this figure right here, obviously has to dilate down to get to this figure here. And then I believe we would have a reflection here. But the question is if this figure right here shrunk down, would it look like this figure over here? And the answer to that is no. Unfortunately, it's harder to see without a few more drawings. But this part right here, this little section right here, would not map onto this section right here. Okay, so yeah, we'd have a dilation down and we could reflect it, but they just wouldn't match up in these two parts right here. So you would have to say no. It would not map it onto it perfectly. Okay? Alright, so that's all we're talking about today when it comes to transformations and similarities. If you have any questions, bring them with you to class, and we will see you then.